Today we start one important topics related to normed linear space. In previous class we also discussed about some closed space and when one space complete implies closed and closed implies complete. When Y be a Banach space of a subspace of a Banach space. Okay. Today we discuss one important theorem, okay, related to these topics. The space C of all convergent sequences in K. Okay, all convergent sequences in K with norm X with norm X infinity equal to supremum of n belongs to natural number mod of xn, okay, is closed in L infinity. Okay, we now prove this one. The space C of all convergent sequences in K with norm this is closed in L infinity. Okay, I write here now. We know that C norm infinity be a complete norm space. Be a complete norm space. Okay, that means Banach space we also known about that. So from last year, that means in previous day we also talk about if complete then this one, that means then this one obviously closed, so this one is done. Okay, that means complete space implies closed. In this way obviously done, this C norm infinity be closed. Okay, closed in L infinity. But we can't do this now. Also going to proof of that. Okay, that means just in not indirect, direct proof of that. Okay, so what we do, we write here let x n be a sequence in C. This not to the power, just suffix n. Okay, let x n be a sequence in C. Okay, such that x to the power n equal to x1 to the power n, x2 to the power n, xk to the power n. Okay, converging to x equal to x1 x2 xk . Okay, obviously this one R belongs to infinity. Okay, we now show that x belongs to C. Okay, then our proof is done. So this implies what? That is x k equal to 1 to infinity be convergent. be convergent. Okay, so this implies again that is xk k equal to 1 to infinity b cos c. Okay, now we start from here. We write let epsilon greater than 0 be given, and since x n converges to x, okay, then what happen? Then there exists n0 belongs to natural number such that norm of x and difference x infinity less than epsilon. Okay, for all n greater than equal to n0. Okay, this implies that we erase our portion. This implies what? This implies that supremum of k belongs to n. Here, x and k difference xk less than epsilon. Okay, for all n greater than equal to n0. This implies that if supremum less than epsilon, then then this implies here xk in difference xk less than epsilon for all n greater than equal to n0 and k belongs to natural number. Okay, for a lower portion also. Now this one is done. Now what we do? We write here, note that, okay, here we write xi difference xj less than equal to xi difference xi n0 plus xi n0 difference xj n0, okay, plus xj n0 difference xj. Okay, obviously we write here ij belongs to n. Okay, so xi difference xi n0, and obviously n0 belongs to n, this less than epsilon, and xj difference xj n0 less than epsilon. Okay, now obviously again we write here x n0, okay, equal to xk n0, here k equal to 1 to infinity be convergent. Okay, since this one be convergent, then this one be Cauchy, then here xk n0 k equal to 1 to infinity be Cauchy. Okay, then what happened? Hence there exists k0 belongs to natural number such that here xi n0 difference xj n0 less than epsilon for all ij greater than equal to k0. Okay, so what happened then? Here ij greater than equal to k0, we write this one, we erase our portion and write here. Okay, what we write? This one xi difference xj less than equal to xi difference xi n0 plus xi n0 difference xj n0 plus xj n0 difference xj less than less than 3 epsilon for all ij greater than equal to k0. Okay, then this implies what? This implies xk is a Cauchy sequence in k. Okay, so we erase that portion and going to further discussion of that. Thus what this implies, what xk, okay, be a Cauchy sequence, be a Cauchy sequence in k. Okay, here k equal to 1 to infinity and here k some field. Since k complete, so here xk k equal to 1 to infinity be convergent. Okay, then what happened? Then obviously x equal to xk, here k equal to 1 to infinity, okay, be convergent. Thus we conclude that C be closed. Okay, so what we get? Convergent, so x belongs to C and C be closed. Okay, that means we construct a sequence and which is convergent in C, so C be closed. Now we also going to discussion of another portion. Obviously we write it some observation. Now here we know about that C00 subset of C0 subset of C subset of L infinity. Okay, so C00 not closed, C00 is not closed. Okay, this one not a Banach space, and obviously it will have Cauchy sequence or some sequence. This one is not converged in this C00. Okay, now we're going to discuss about C0. The set of all convergent sequence in K with non infinity is closed in on C. We erase that portion and going to further discussion of that. Okay, So we write here in theorem from, okay, the space C0, the space C0 of all convergent sequence, all convergent sequence in K with norm x equal to supremum of K belongs to N. This one is mod of xk. Okay, be closed on C, be closed on C 0. Okay, sorry, be closed. Okay, then not C0 space is closed in on C. That means C0 obviously belongs to C. Okay, C0 set of all convergent sequence C be the set of all convergent sequence and C0 be the set of all convergent sequence which converge to 1, which converge to 0. Okay, so what we do now, we write here, let xn be a sequence let xn be a sequence in C0, okay, such that xn equal to x1n, x2n, x3n xkn. Okay, and converging to x equal to x1, x2, x3 xk . Okay, this one belongs to C, not C0. Xn be a sequence in C0 such that this converts to X. Okay, then C0 be closed. So we have to show that X belongs to C0. Okay, now this implies that is xk equal to 1 to infinity converging to 0, converging to 0. Okay, now let epsilon greater than 0 be given. Let epsilon greater than 0 be given. Sin x to the power n converges to x. Okay, then there exists n0 belongs to natural number such that norm of x in difference x, okay, infinity less than epsilon for all sorry here for all n greater than equal to n0. Okay, then this implies that what supremum of k belongs to natural number xk whole to the power n difference xk less than epsilon for all n greater than equal to n0. And okay, now we erase our portion and going to further discussion of that. Okay, so what happened, I write it now, xk whole to the power n difference xk less than epsilon for all n greater than equal to n0. Okay, now take here mod of xk less than equal to xk different xk n0 plus xk n0. Okay, here k belongs to n and n0 obviously belongs to n. Okay, so what happened, this one obviously here we put n0, then this one less than epsilon plus xk n0. Okay, now we also erase that portion. I'm going to further discussion of that. Since xkn, sorry, we write particular n0 be convergent to 0. This one is in C0, so this one happened. So there exists k 0 belongs to natural numbers such that what such that xk n0 less than epsilon or for call k greater than equal to k0. Okay, now we write here xk less than here epsilon plus epsilon for all k greater than equal to k0. This implies mod of xk less than 2 epsilon for all k greater than equal to k0. Okay, then what happened, so xk k equal to 1 to infinity converges to 0, converges to 0. Okay, then what happened, then x equal to xk k equal to 1 to infinity obviously belongs to c0. Okay, so c0 be closed. Okay, so today we stop here, and if you get this type of videos, then obviously that means subscribe this channel, and if you like, then obviously press like options, and any questions arise in your mind and any problem occur, then obviously please share it in comment box. So today I stop here.